So for E, numbers 5 and 11. So for each list below, work out the average, the deviation from average, and the SD. I don't really care about the deviation from average. Well, if you're doing it by hand, then you have to write it out, right? It wants to know how far is each one from the average, but we don't care about those numbers. We just care about the SD. So I'm going to plug it into my stat and have the calculator do all the work for me. So I go up to L1 and I push clear, not delete. Clear, enter, and then I put in the numbers 1, 3, 4, 5, and 7. Then I go back into stat, I go to calc, and I do a one variable stat, and my SD is 2. Average is 4, SD is 2. Okay, for the next one, 6, 8, 9, 10, and 12. I run my one variable stat, and now my standard deviation is 2 and my average is 9. So how is list 2 related to list 1? They have the same standard deviation. What does that mean? If we do the distances from average, they're exactly the same. So how does list 2 compare to list 1? It's exactly 5 points bigger with every number. Do you see that? So remember when we did these graphs? What's the difference between those two graphs? We just added 5 to the first one to give us the second one. We just slid it right over. Does adding 5 to all the numbers change the SD? No, because it's no more spread out than it was before. So simply adding 5 to one list is just going to change how big it is, but the SD isn't going to change. Okay, number 11, can the SD ever be negative? No, why not? You square all the distances, which turns it positive, and then you take the square root.